All right, so in this video, we're going to talk about right triangle trigonometry, which is essentially what we've been doing all along. All of the trig functions are based upon using right triangles. But right now, we're going to change the picture a little bit to looking at a right triangle not associated with a coordinate plane. So there's no x and y axis. You can view this as just a free-floating triangle, if you will. So if we call that angle theta, instead of x's, y's, and r's, because again we don't have the xy plane anymore, we can view things as opposite, adjacent, and hypotenuse. So it's pretty clear that the longest side here would be the hypotenuse. The side opposite angle theta we'll call OPP for opposite. And then the adjacent side would be the one marked ADJ for adjacent. Now, all of the trig functions, again, still work here because we have a right triangle. So to redefine them, if you will, sine of theta, instead of being the y over r from before, you can see that would be the opposite over the hypotenuse. Cosine of theta, instead of viewing it as x over r, would now be the adjacent over the hypotenuse. And then tangent of theta, instead of being y over r, would be the opposite over the adjacent. Now, in the first example, we're going to be solving triangles. And to solve triangles, the easiest way, and then probably the most consistent way to do this, is to have a triangle drawn, a right triangle. And we generally say that if we have an angle alpha, the side opposite alpha we would call A. If we have an angle beta, the side opposite beta would be B, and then the hypotenuse we'll call C. So in these problems where we're told to solve the triangle, we're going to be given some of the information, and it's up to us to find the rest. So in these particular problems, assuming we have a 90-degree angle, there's going to be 1, 2, 3, 4, 5 pieces of information collectively that will either be given or we have to find. So I'll go ahead and put the example 1 up on the screen. All right, so here's the example 1. I've also included the triangle that I had in the last picture. And so you can see we are given beta, we're given B, but we still need to find A, C, and alpha. Now, probably the easiest one to find is angle alpha. We know that there's 180 degrees in a triangle, so if I take 180 degrees minus the 90 degree minus the given beta, that's going to leave us with alpha. So 180 minus the 90 degrees minus the 19 degrees 12 minutes, and remember that was beta. That should give us what alpha is. So by punching those numbers in our calculator, you can see that alpha would end up being 70 degrees and 48 minutes. So there's our alpha. All right, so that one's taken care of. Now, to find A or C, this is where we'll have to resort to some of the trig functions. You actually have a couple options here. Now, as a general rule, I would recommend using given information as opposed to found information. If you had made a mistake in finding, let's say, alpha, and you use it in the next step, then that would also be incorrect. So I would use beta if at all possible here, since it's given information. So one of the options would be to investigate sine of beta. We know that sine of beta from our last slide would be the B over C. So the opposite over the hypotenuse. And for us then, sine of 19 degrees 12 minutes would equal B, B is 60, over C, which is what we're looking for. So C then is going to be 60 divided by sine of 19 degrees 12 minutes. And if you punch that into your calculator, you end up with 182.4. if we round to 1 decimal place. All right, so now it looks like we've found C. The only missing part that we still need then would be the A. And so the easiest way to do this would actually be the Pythagorean theorem. We know that by the Pythagorean theorem, A squared plus B squared equals C squared. The A squared is what we're looking for. B squared would be the 60 squared plus, and then, equals the C squared. Now, the 182.4 squared is what I'm going to write on the screen, but remember this is a rounded number, so try not to use the rounded number in the next calculation. Use the number that's in your calculator. The store and recall button work great for something like this, so that's something to consider. So A then would equal the 182.4 squared minus the 60 squared, all square rooted, which give us 172.3 for an A value, rounded to 1 decimal place.